Welcome back to Think Cosmos, where we ponder the universe's deepest secrets and wonders. We usually picture black holes being born in dramatic ways. A massive star goes supernova, collapses, and boom, you've got a black hole. But what if a black hole could form quietly, hidden inside a star without any explosion at all? It sounds like a sci-fi horror story. A star living a normal life on the outside, while a tiny black hole secretly grows at its core, slowly devouring it from the inside. Incredibly, new research suggests this might actually happen. This discovery opens up a wild new scenario in astrophysics, one where some stars harbor endoparasitic black holes, essentially cosmic parasites that could eventually consume their hosts. Let's unpack how this could be possible and what it means. The mystery starts with some puzzling observations of tiny black holes. Gravitational wave detectors like LIGO have picked up signals from merging black holes that are surprisingly low in mass, some even smaller than our sun in mass. According to our standard theories, a star that's small shouldn't collapse into a black hole naturally. It takes a star much heavier than the sun, ending in a huge supernova, to create a black hole in the usual way. So where are these near-solar mass black holes coming from? One intriguing idea is that they might not come from normal stellar death at all, but from something more exotic like dark matter. Dark matter is this invisible stuff that pervades the galaxy. We know it has gravity, but we don't know what it is made of yet. The theory suggests dark matter particles could drift into a star over time, collecting at its center, since they feel gravity but hardly interact with normal atoms. Over many millions or billions of years, enough dark matter might accumulate in a star's core that it effectively tips the star into a collapse. The core could quietly crunch down into a small black hole without a supernova bang. The star doesn't blow apart. Instead, it suddenly has a tiny black hole seed in its center. It's a bit chilling. On the outside, the star might appear almost normal, shining on, but deep within, a devourer has awakened. What happens once a black hole forms inside a star? Now we have this scenario. Let's imagine particularly a white dwarf star, the leftover core of a sun-like star, which is a very dense, Earth-sized object. The research looked at white dwarfs because they're dense and can stick around a long time, making them prime candidates for such hidden black holes. Once the black hole seed is there, it will start eating star from the inside, pulling gas in and growing. But the fate of this internal takeover actually depends a lot on the star's spin. The scientists outlined 3 possible outcomes. If the star, white dwarf, is spinning slowly, nothing much stops the black hole from gobbling up material. It's like water going down a drain, relatively unimpeded. Over time, the black hole would consume more and more of the star's mass. Eventually, the entire star just collapses into the black hole. What started as a star ends as a slightly bigger black hole, quietly, without an external explosion. From the outside, you just see the star gradually dim and disappear as mass falls in. If the star has a certain moderate spin, something really bizarre could happen. The collapse overshoots in a weird way and potentially forms a naked singularity. Normally, black holes are clothed by an event horizon, a boundary beyond which nothing can escape. A naked singularity is a theoretical object where the singularity, the infinitely dense core, is exposed with no horizon. That breaks a lot of our intuitions and possibly the rules of physics as we know them. It's a highly speculative outcome, but this scenario suggests an internal collapse could, in principle, produce a naked singularity if conditions are just right. It's mind-bending. Such an object would challenge Einstein's relativity and be a window into new physics. If the star is spinning very fast, an interesting stalemate can occur. The rapid rotation and internal pressure of the star might slow down how quickly the black hole eats. In fact, the research suggests that accretion, matter falling in, can stall. Picture the star's spin kind of flinging material outward, or at least resisting the infall to an extent. The black hole still grows, but extremely slowly. The result is a long-lived hybrid. The star survives, shining and spinning, but with a small black hole lodged at its core. This is what they dubbed an endoparasitic black hole. Endo meaning inside, and parasitic for obvious reasons. The star keeps living its life, perhaps for a very long time, all while being secretly hollowed out at the center. From afar, it might look like an ordinary white dwarf star in many ways, but it's essentially a shell with a tiny black hole and some surrounding stellar material in equilibrium. These outcomes are theoretical, but they paint an astonishing picture of how varied the life cycles of stars could be if these hidden black holes are real. Why does this matter? What could we observe or learn from this? If black holes can grow silently inside stars, this might solve multiple puzzles. For one, it provides a natural explanation for those mysterious low-mass black holes turning up in gravitational wave data. They might literally be former white dwarfs or other stars that quietly collapsed via this process. If two such silent black holes form inside two stars in a binary system, they could eventually spiral together and merge. That merger would generate gravitational waves that our detectors pick up. We'd think, how did two one-solar mass black holes exist? Well, here's a pathway. Another implication is about dark matter. If we find evidence of these processes, it hints that dark matter particles can accumulate and trigger star collapses, giving us indirect clues about dark matter's nature, like how strongly it can clump and interact. Moreover, thinking about endoparasitic black holes broadens our understanding of what a star can be. Could there be stars out there right now, harboring small black holes, showing odd behaviors? Perhaps they might emit unusual X-rays or have weird pulsations as the internal black hole's gravity messes with them. Astronomers could start looking for signs like a white dwarf that's unexpectedly dimming or massive for its size, as hints of an internal collapse. It's also a new twist on the life cycle of stars. We typically classify stars as going supernova or quietly cooling as white dwarfs or exploding as gamma-ray bursts, etc. Now there's a possible stealth mode of stellar death. This is all cutting-edge theoretical work, so there's plenty of healthy skepticism. But it's exciting because it shows how creative astrophysics has to get to explain new observations. We might have to accept that some black holes are born not with a bang, but a whisper, a kind of secret death inside a star. Closing thought. The notion of black holes quietly emerging within living stars is both eerie and fascinating. It reminds us that the cosmos might have many undiscovered pathways and hidden transformations. Imagine looking up at a star, twinkling innocently in the night, not knowing that deep inside it has already become a black hole's home. It's almost like a cosmic Trojan horse story. Could there be such infected stars lurking even in our galactic neighborhood? If so, the reality of stellar evolution is far more rich and strange than textbooks once taught. It leaves us pondering profound questions. What truly counts as the death of a star? And might understanding these stealthy black holes help us finally bridge the gap between dark matter and normal matter in the grand story of the universe? This new idea challenges us to rethink what's possible, and serves as a reminder that there are secrets still hidden in the hearts of stars.